In this example, we want to explore the usefulness of a common formula called the voltage division formula. And here's how it works. If you have a resistor, or two resistors, R1 and R2, and let's say there is a fixed voltage across them, call it Vs, and what we're wondering is, what is the voltage, how is the voltage apportioned across these two resistors? Now from KVL we know that V1 plus V2 is equal to Vs, but how does the voltage split? It turns out that the voltage division formula gives you this nice little ratio. The voltage across R1 is equal to the resistance R1 divided by the total resistance in the loop times the total driving voltage. And similarly, the voltage across V2 is the voltage across R2 is the resistance R2 over R1 plus R2 times the total driving voltage. If there were three resistance, okay, R1, R2, R3, and again we had the same driving voltage, now we would have V1 would be equal to the resistance R1, because that's the voltage, the element across which we're trying to determine the voltage, divided by the total resistance in the loop. So R1 plus R2 plus R3. Now let's just derive this. Let's find the current that is flowing in this loop. Call it I. I is equal to the total voltage that is forcing a current divided by the total current in that loop. R1 plus R2. Okay, now we could arrive at this by writing KVL, and I'll do that just for reference here and just for practice. Let's start at the bottom left and we'll go clockwise. So we encounter V1 plus V2 minus Vs is equal to 0. But V1 is equal to R1 times I. V2 is R2 times I. So now we can write R1 plus R2 times I is equal to, we'll bring Vs on the other side, and now we solve for Is as being Vs over R1 plus R2, and we see that's the same as what we wrote by inspection. Now once we have the current flowing in this single loop, we can now write the voltage across R1 as simply V1 is equal to R1 times I. But I is this ratio here, so we can write it as Vs times R1 over R1 plus R2. And you can do the same thing for the voltage across R2. So that's how we derive the voltage division formula. But here is the formula that we will use. So let's apply it to this problem over here on the left. We see more than just two resistors. However, these two are in parallel. So the parallel combination of 6 in parallel with 3 is equal to 6 times 3 over 6 plus 3. So that's 18 divided by 9, which is 2 ohms. So what we have is a 4 ohm resistor in series with a 2 ohm resistor, and we're applying a total of, well, I threw in a little complication here. We don't have a constant voltage source here, but that doesn't change anything. We'll just call this Vs for the moment, okay? And we'll plug in at the end the actual form of Vs because it's a sinusoidal signal. And we're asking for the voltage Vx. Well, we can just do that by the voltage division formula. Vx is the voltage across the effective 2 ohm resistor, the resistor that results from 6 and 3 ohms being in parallel. So that's 2 ohms divided by 2 ohms plus 4 ohms times the total voltage that is driving that series circuit. And so that's 2/6 or 1/3 times Vs, which is 1/3 of 12, so that would give us 4 sine of t. Okay, and that is, I'm sorry, that's not Vs, that's Vx here, Vx. Put some units on here, that's volts. That's how the example of how the voltage division formula comes in handy.